Hello once again. This is Teacher King David. We are still on the visual question is about complex numbers. So we have number 11. Number 11 is saying find the value of the complex number. We have the complex number z, which is negative half plus I 3 over 2, then power 2010. Leave your answer in the standard form. The question is like, how can you express this in algebraic form? Already it is in algebraic form, but how can you find this on power 2010? Then we leave the answer in the algebraic form. So our z is negative 1 over 2 plus I root 3 over 2, then power 2010. That is our complex number. So we need to leave this complex number in the form of z equal to a plus bi without any power. So what you do, if you remember, we use the Mover theorem. So when you have z equal to x plus yi, we can express this algebraic form into polar form, where z equal to r into bracket cos angle plus I sine angle. I think remember r is the modulus of z and angle is the argument of z. Then what is z power n? Z power n by using the Mover theorem, it is r power n into bracket cos n angle plus I sine n angle. This is the modulus theorem. So z power n is equal to r power n cos n angle plus I sine n angle. So which means that we need the argument of z. We need the argument of z, which is the angle, and we need the r, which is the modulus of z. How do you find the modulus of z? You know that is the square root of x squared plus y squared. Okay. Then from there, let's first find the modulus. Our r will be equal to square root. We're going to find the modulus. Our x is negative half. Our y is root 3 over 2. That's negative 1 over 2 squared plus root 3 over 2 squared. So what is the answer there? Our r is, that is square root of 1 over 4, then plus 3 over 4. You see now, the answer is root 4 over 4, which is 1. Square root of 1 is 1. So our r is 1. We have 1. Then what is the argument? So we need to find tan alpha. Tan alpha will be y over x. So then tan alpha will be equal to root 3 over 2 divided by a half. I told you we don't consider negatives. Negatives, they help us to know where that z is located in terms of quadrants. So tan alpha will be equal to root 3 over 2 times 2 over 1. Tan alpha will be equal to root 3. Then alpha is tan inverse of root 3. So what is tan inverse of the root 3? We use a calculator to find tan inverse of what? Root 3. Then tan inverse of root 3, it will be equal to tan inverse of root 3 So we have 60, which is pi over 3. Our angle is pi over 3. But remember, if we use quadrants, so we have x-axis. On x-axis, we have negative half. It is on the here. Negative half to be fine. You will find it in this side. Then y, it is root 3 over 2. It is in positive sides of y. You see, it will be here in the second quadrant. And in the second quadrant, if you remember very well, in the second quadrant, angle equal to pi minus alpha. That is in the second quadrant. So which means that our angle will be equal to pi minus pi over 3 because our alpha is pi over 3. So now the answer is 2 pi over 3. So this is the argument. So the argument of z equal to 2 pi over 3. So from there, what are we going to do? So we're going to use that formula because now z equal to r is 1. So it will be cos 2 pi over 3 plus I sine 2 pi over 3. So what is z power 2010? Z power 2010, the answer is cos, it is cos 2010 times 2 pi over 3 plus I sine 2010 2 pi over 3. So that answer, which is that value which is negative half plus I to 3 over 2 power 2010. The answer is, so when you reach here, what you do, you use the calculator. You take this one times this, then you use what? You find the cos of that one. So actually this is like 120 times 210. Then it cos of 210 times 120. The answer is 1. Cos of this one answer is 1. Then I'm going to do for sine. Sine of 2010 times 120. Sine of 2010 times 120. So the answer is 0 plus 0 I. So which means that our z, which is equal to negative a half plus I to 3 over 2 power 2010, its answer in algebraic form is 1 plus 0i, which is the same as 1. You can write 1 or you write 1 plus 0i. I hope you don't have any question there. So let us go to number 12. We have completed the number 11. So and the number 11, you know that is number 13, Lab 2011. That's where you can find it. Okay, let's go to number 12. Number 12 is saying, we have number 12a. Consider the quadratic polynomial where you have z squared minus 6z plus c, where c is a real. It is a real number. For what values of c does this polynomial have real roots? That's number 12a. So we have our quadratic polynomial, which is z squared minus 6z plus c. So for which values of c where this polynomial has real roots? So it has real roots. It has real roots if and only if the discriminant, which is delta b squared minus 4ac, is greater or equal to 0. So it has real roots when discriminant, which is b squared minus 4ac, is greater than or equal to 0. So now, from, when you have like az squared plus bz plus c equal to 0. So discriminant is b squared minus 4ac. So from there, our a is 1 when you compare this one with that one. Our b is negative 6. Then our c is c. You see, c will be equal to that c. So then, what is delta? Our discriminant there is b squared, which is negative 6 squared, minus 4a, which is 1, c, which is c. So meaning that it will be 36 minus 4c, which is greater than or equal to 0. Because this polynomial will be, it will give us real roots when its discriminant is greater or equal to 0. So now this will be equal to, it will be greater than or equal to what? To 0. So let 36 minus 4c be equal to 0, where 4c equal to 36, where c equal to 36 divided by 4, that's 9. So now this is inequality. We have to start a sign. So we have c here because it is a variable. So we have negative infinity to positive infinity. So the value of c is 9. Our equation is 36 minus 4c. When you bring 9 here, we get 0. So this side, because we have a negative here, this side will be positive. Or we choose a number between negative infinity and 9. There is 0, there is negative 5. Let's use 0. When c is 0, that is 0. 36 minus 0, that's 36, which is positive. So when you choose like between 9 and positive infinity, there is 10. Let's put 10 here. 10 times 4, that's 40. 36 minus 40, that's negative 4. Here it will be negative. And remember, we have greater. Greater means positive. So mean that c will be a member of from negative infinity excluded to 9 included. So that's the values of c. The values of c will be from negative infinity excluded to 9 included. So that's the answer for A. So I hope there is no any question about number 12A. Do you have any question? Okay, let us proceed. So we have completed the number 12A. Let's go to number 12B. So number 12A and B, so you can find them in number 17, 2011. So 12B is saying multiply out the expression. That's the first question. Multiply out the expression. What is that expression? It is this one. We have z plus 7 into bracket z squared minus 6z plus 25. Just when we need to multiply, it's like expanding. Then after expanding, hence find all roots, real or complex, of the polynomial. So let's first expand this one. We'll see what it's going to give us. Okay, z times z squared, this is z power 3. Z times negative 6z, that's negative 6z squared. Z times 25, that is 25z. Then 7 times z squared, that is z squared. 7 is z squared. 7 times negative 6, that's negative 42z. Then 7 times 25, that is 175. It is 175. So finally, z plus 7 into bracket z squared minus 6z plus 25. The answer is, we have z power 3, then we have negative 6z squared, and also we have, there is negative 6, sorry, we have a negative 6z squared plus 7z squared. 7z squared minus 6z squared, that is z squared. So we have 25z minus 42z. So 25 minus 42, that is negative 17. Negative 17 is z. Then plus 175. So that is expansion of this one. After expanding, so the answer is this one. You see now, we have this polynomial, which is z power 3 plus z squared minus 17z plus 175. Then The question is saying, hence find all roots of this polynomial. If you can check very well, this polynomial is the same as this one. So what does it mean? We're going to let this polynomial to be equal to 0. Let z power 3 plus z squared minus 17z plus 175 be equal to 0. So if this polynomial is equal to 0, so we need to factorize this polynomial. No need of struggling factorizing this polynomial because it is already factorized here. So which means this polynomial is the same as that. So it will be z plus 7 into bracket z squared minus 6z plus 25 equal to 0. You know, when you have two products equal to 0, it means that this one is equal to 0 or this one equal to 0. So meaning that z plus 7 equal to 0 or z squared minus 6z plus 25 equal to 0. So let's first deal with this one. From z plus 7 equal to 0, it means that z equal to negative 7. This is the first root. So let's go to this root. I mean this quadratic equation. Then z squared minus 6z plus 25 equal to 0. Our a is 1, our b equal to negative 6, our c equal to 25. So we're going to use quadratic formula. Quadratic formula says when you have z, it will be negative b plus or minus b squared minus 4ac divided by 2a. So z will be equal to negative, that is 6 plus or minus square root of, b squared, that is negative 6 squared, that is 36, minus 4 into bracket, our a is 1, c is 25, divided by 2 times 1, which is 2. Then z equal to 6 plus or minus square root of 36 minus 100 divided by 2. So z will be equal to 6 plus or minus, that's 6 minus 100, that's negative 64, root negative 64. And you know square root of a negative number, you know that negative 1, which is under square root, negative 1 is I squared. So that is z equal to 6 plus or minus root 64 I squared divided by 2. So z will be equal to 6 plus or minus, you know, I squared, the square root of I squared is I, that is I, square root of root 64, that's 8. So we'll get what? We're going to get 8i divided by 2. So let me call it like z2. We're going to take 6 plus 8i, we divide by 2. The answer is 3 plus 4i. 6 divided by 2 is 3, 8 divided by 2 is 4. So z3, the answer is 6 minus 8i divided by 2. I'm using this because we have plus or minus. So 6 divided by 2, that is 3. 8 divided by 2, that is 4. You see, those are two roots. With this one, we have 3 roots. We have 3 roots because our polynomial is third-degree polynomial. So our set contains 3 roots, which are negative 7, 3 minus 4i, 3 plus 4i. That's the answer. I hope you don't have any question here. So let us go to other numbers.